In recent times, the COVID-19 pandemic has required people to increase security and health protocols to decrease the number of infections and possible casualties the virus can bring. Unfortunately, this also means that there are more processes people have to go through when entering some establishments or locations, and some people have to be assigned specifically just to monitor this. According to World Health Organization 2021, most people nowadays are infected with COVID-19 virus. Furthermore, the virus already reached numerous countries globally, such as Singapore, Japan, United States, and many more. The World Health Organization mentioned that the COVID-19 virus spreads primarily through droplets of saliva or discharge from the nose when an infected person coughs or sneezes. This means people must take effort to follow our safety protocols that has been implemented by the government. People follow health safety precautions by wearing face masks and spraying alcohol on their hands for safety. Yet, this is not the perfect way for everyone to determine their safety. Based on WebMD 2021, the main symptoms of COVID-19 are fever, coughing, shortness of breath, fatigue, chills, body aches, sore throat, runny nose, loss of smell or taste, nausea, and diarrhea. The virus might also lead to pneumonia, heart and liver problems, septic shock, and death.
The researchers plan to research and develop this system for the future so that could be used during the pandemic. This system will be based on a temperature sensor to detect a person's temperature and movement for its activation. The researchers are designing this said machine to ensure the people's protection by avoiding physical contact with an alcohol dispenser along with a non-contact temperature device all the time in order to prevent contact with others. The system will also alarm the officials nearby who are responsible for doing their tasks once someone is suspected of having virus. The researchers want to make this possible by using an electronic temperature scanner which tracks who enter the records of people temperatures to ensure that people do not have a chance of getting COVID-19 while reducing the risk.
The researchers' goal is to test the effectiveness of a temperature sensor-based system with an automated alcohol dispenser. In line with this, the researchers have come up with the following questions. First, what is the accuracy of the temperature-based sensor systems in detecting feverish temperatures? Second, how much time can be saved in monitoring people's temperatures using the temperature-based sensor system compared to the manual process? Last, can the temperature-based sensor system lessen the dependence on manpower for monitoring people's temperatures? This study will assess the efficiency of a robotic system as a replacement for manual work. This will also test if the conceptualized system would work.
Scope and limitations. Specifically, this study evaluates how dependent the system would be in place of manually taking the temperature of people with infrared thermometers, how efficient it would be based on time, and how much time would be able to save. This study is only limited to the variation of the security system that only depends on a temperature sensor as a way of detection. The study will also focus on two simple basic functions, which are the functions of automatic alcohol dispensing and a sound alarm triggering on fever temperature. This study will reduce the amount of time and manpower it will take to maintain the security of an establishment by automating it through robotics. This would also reduce the close contact required when performing security checks and possibly contact tracing.
The materials used in the research are an alcohol pump, a piezo to act as an alarm, an LED, in this case red, and a resistor for it, a USB power adapter to power the Arduino, and jumper wires to connect the system. The researchers will also use an Arduino Uno to command the functions of the system, a USB Type A to B cable for programming the Arduino, a temperature sensor, and infrared sensor to detect inputs, and a servo motor to automatically pump the Arduino. Buying and preparing the materials. Buy the previously mentioned materials needed and prepare them all together. Assembling/building. The first thing to assemble is the Arduino together with the sensors, piezo, LED, and the servo. Refer to figure 4 for placements. Each of the components will connected with jumper wires as seen on figure 2. Attach it properly to avoid malfunctions, and for loose parts, connect it with electrical tape.
Plug the USB cable from the Arduino into the laptop or computer to use the Arduino coding platform app. Open the platform and input the required code for the project. Try to simulate the program and check if it's working properly. Finally, pass your hand by the temperature sensor and see if the alcohol dispenser activated. Also, get water to 37.2 degrees Celsius or a little over and pass it by the temperature sensor to see the alarming function works.
The materials used for the research were an Arduino which costs 149 pesos, a temperature sensor which costs 455 pesos, an infrared sensor which costs 17.6 pesos, 14 jumper wires which collectively costs 23.1 pesos, a USB power adapter which costs 50 pesos, an LED, in our case red, which costs 4 pesos, a resistor which costs 50 cents, a piezo which costs 9 pesos, a servo which costs 100 pesos, an alcohol dispenser bottle which costs 27 pesos, electrical tape which costs 35 pesos, and the USB Type B to A cable which costs 30 pesos. All of our materials were purchased from Lazada, and in total, all our expenses totaled to 900.2 pesos. This concludes our research.